We are given an array where each element represents the height of a vertical line on the x-axis. We want to find two lines that together with the x-axis form a container such that the container contains the most water and return the maximum amount of water a container can store. In this example, the left line has height 8, the right one has height 7, the shorter height is 7, the width is also 7 as shown in the shaded blue. The maximum area is 7 times 7 equal to 49, which is the answer. Let's take another example height array and plot it on a graph. We place indices I and j at these positions. How do we find out how much water can be held between these two vertical lines? To do that, we take the smaller of the two heights and calculate the distance between the indices, that is j minus I. We multiply them and the result gives us the area of water contained. We use the minimum height because if we try to fill water above that, it would simply spill over the shorter line. The most intuitive approach is to check every possible pair, start with I, move j forward, compute the area each time, while keeping track of the maximum area so far and updating it at each iteration. This approach, however, takes O of n squared time. Can we do better? Yes, we can, using a clever two-pointer technique that brings it down to O of n. We keep the pointer I at index 0 and pointer j at the last index. At each step, we take the minimum height between the two lines, calculate the area, and update the maximum area so far if it's larger. Now, which of the two pointers should we move? We move the one pointing to the shorter line because only a taller line might help increase the area. Moving the taller line wouldn't help because the area would still be limited by the shorter height. In the next iteration, we move pointer j because it's the shorter line and calculate the area. Then we move pointer I since now it's the shorter line. We repeat this while I is less than j, and once that's no longer true, we stop. The maximum area we found during this process is 9, and that's our final answer. And here is the code for this problem. We find the shorter of the two heights and the distances between indices I and j. We compute the area and update the maximum area so far. Then we move the pointer that points to the shorter line. We repeat this process while I is less than j, and finally we return the maximum area.